Okay, so the next linked list question is called copy list with random pointer. This time we'll be using node and not list node, and the main difference is that we have the new parameter random. This random is just going to be pointing to one random node inside of our linked list. And what we're asked to do is to create a deep copy of our whole linked list that is constructed using node. So the problem that we're going to be facing is the fact that all the nodes in the next and random should be pointing to the two nodes in the copied linked list. So it shouldn't point to any node that exists in the original or the given linked list called head. And we will return it. So we not change it in place. Obviously, we will return it. And I mean, in the case of if there was no random, what's gonna happen is we could just iterate through our lists, and we will copy each node, deep copy each node, and create the next, and so on until we reach the end. But in this case, we'll have to create a dictionary and check if for each node there is already a deep copy created or a clone created for that node. So the key is going to be the node on the original list, and the value is going to be the cloned node. So I'm going to put it in a init. So diff underscore init of self. We'll do self that cloned, I guess, equals to dict. And I'm gonna create a getter. The reason is what it's gonna do is instead of just getting the cloned node, if it hasn't been already cloned, it will clone it. So it's gonna create a new node object and then put it in the cloned dictionary. So diff get cloned node. So we'll take in the original node, the node that exists in the original linked list. So if if node, so if the node is not none, else if the node is none, then we will return just none. Now we will check if it exists or not. If node not in self.cloned, in that case we'll need to create it. So new underscore node equals to node, and we will take the value node that's val, and this could be none. And it's not really important because we got default value is none and none here. So we created the node, so we'll need to add it by doing self.clone of the original node equal to new node. I can call it clone node, but in either way we'll return self.cloned node, the newly created node or the node that already exists in cloned. Now we'll go to the main part of our solution. So we'll check the edge case if, for example, head, if not head, right? So if it's none, then just return none. Now else, what are we gonna do? First, we'll need to create our new head. I'm gonna create a new reference for both. So I'm gonna create old lists or old node, probably old node equals to head, and new underscore node equals to node. I'm gonna do old underscore node the value. I mean, instead of doing this, I could just use the getter that we created. So we'll do self dot get cloned node, right, of head or old node. It's the same thing. So while new old underscore node, while we still haven't reached the null or none case, I mean, I'm gonna do this first. Return self.cloned of head, right? So the cloned head is the head of the newly created linked list. And here, what I'm gonna have to do is manage the next and the random and iterate through both the linked lists. So I'm gonna do old underscore node equals to old underscore node dot next, and new underscore node equals to new underscore node dot next. and we will get our next first equals to get self dot get cloned node of old underscore node dot next, right? And then new underscore node. This time do the same thing for random. Check get cloned node. That is the same name, get cloned node. Okay, so we create a clone dictionary. The key is the old node, and the value is the new value, right? New cloned node. This makes sense. Return the cloned of the head. Okay, okay, it's all is good.